Good afternoon, student. Our next topic is the zone plate. Zone plate is an optical device which works similar to a lens and provide an experimental arrangement of the Fresnel theory of a half-period zone. It consists of the large number of the concentric circle whose radii are the proportional to the exact square root of the natural numbers 1, 2, 3, and so on. The alternate even or the odd annular region are completely blackened. The light can be cut off by either blackened even zone or the odd zone. To construct this zone plate, we draw the concentric circles on the paper such that the radii are proportional to the square root of the natural numbers. Then the odd number zone, that is first, third, and the fifth, are colored with the black paint and the photograph is taken. Then the negative of this photographic plate thus obtained act as the zone plate. Here is the figure shows the odd zone are the transparent to the incident light while the even zones are the opaque here in this figure. When the central zone is transparent, here the central zone is transparent, then the zone plate is called as a positive zone plate. And if this central is a opaque, then this zone plate is called as a negative zone plate. Then theory, let S be the monochromatic source of a light of wavelength lambda and AB be the section of the zone plate. This is the zone plate, and where we consider the section means take the one part of this zone plate perpendicular to the plane of paper like this. This is the section of the zone plate. Here we consider AB is the section of the zone plate, S is the source of monochromatic light, and P is the point on the screen. This source here, this is the section AB. From this source, this point O is at the distance A, and from this screen this section is at the distance B. Let P be the point on the screen. Here P is the point on the screen. Then according to the theory of the half period zone, OM1, OM2, OM3 and so on are the radii of the first, second, third, etc. half period zone. Here that M1, M2, M3, Mn are considered as the half period zone. Therefore, we consider this OM1, OM2, OM3, OMN are the radii of this zone, half period zone, and this is considered as the R1, R2, R3 and the so on. The half period zone are such that the path difference between any two consecutive zone is lambda by 2. As we study in a Fresnel half period zone theory, that the difference between the two half period zone, that is this OM1 and OM2, is the lambda by 2. This is the path difference between these two half period zone is the lambda by 2. Therefore, if we consider this SM1 plus M1P distance, means this distance as M1 plus M1P distance, then it is written as SO plus OP differ by the lambda by 2. This is the difference between the two half period zone is the lambda by 2. Therefore, the path difference between these two waves and two lines is a lambda by 2. Therefore, we add here lambda by 2. This SO is nothing but the A and OP is nothing but the B here. SO is A and OP is B. Therefore, we substitute this value A plus B plus lambda by 2. Similarly, the SM2 plus M2P, then there is the part difference from this O to this level is a 2 times of lambda by 2, which is written as 2 lambda by 2. Similarly, if we take the third, it means 3 times of the lambda by 2 is add here. Therefore, we take here SO plus OP 3 lambda by 2. In this way, we take the number of zone plate. For the nth zone plate, it becomes SMN plus MNP, which is equal to SO or plus OP plus nth lambda n into lambda by 2, means n times this lambda by 2 is differ by the part difference. Therefore, we take the n lambda by 2 here. Then we get a plus b plus n lambda by 2. This is equation number 1. Then from figure we consider this triangle SOMN and then apply the Pythagoras theorem. Then by applying the Pythagoras theorem, this is the hypotenuse side. We will get SMN square plus equal to SO square plus OMN square. This is the Pythagoras theorem. Here then SMN square equal to SO is nothing but the A here. Therefore we take this A here, and OM is the radius of the half period zone. OM, which is taken as the Rn, which is then it will become Rn square. Then SM equal to A square plus Rn square bracket to the power half. We remove this square here, therefore it become the square root. Then take the common A here, then it become A into in bracket 1 plus Rn square upon A square bracket to the power half. If suppose we take this A common here or A outside the bracket, means that A square and the power half, it will get cancelled, only we get the A, and here in the bracket we will get this term here. Then solve the exponential series for this term. Then we get approximately value A into bracket 1 plus Rn square upon 2n square. The higher order term of this exponential series get neglected because this A and A term is very much greater than the lambda. Therefore, we neglected the higher order term here. Similarly, here therefore this term is approximately equal to this term, which can be written as equal to the SM equal to the A plus Rn square upon 2A. If we multiply A to this term, we will get A plus Rn square upon 2A, gives the equation number 2. Similarly, if we consider POMN triangle, and again by applying the hypotenuse rule and solving by this method, finally we get this equation. Mn P equal to B plus Rn square and Rn square upon 2B, the equation number 3. Now substituting this value in equation 1 means the value of SMN and MNP here. SMN and MNP in equation 1, we have to substitute this value. Then after substituting, what we get here, we substitute the value, we get A plus Rn square upon 2A plus B plus Rn square upon 2B, which is equal to A plus B plus n lambda by 2. This is this equation. Here we get, finally we get A plus B n lambda by 2. Here we substitute this 2 value here. Then finally we get this equation. Then take the here A, if we solve this bracket, we get A plus B plus Rn square 2A, Rn square upon 2A plus Rn square upon 2B equal to A plus B plus n lambda by 2. This A plus B and A plus B will get cancelled here. Then the remaining term will be Rn square upon 2, and the bracket means here we get, if we solve this bracket, this term will get A plus B plus Rn square upon 2A plus Rn square upon 2B, which is equal to A plus B plus n lambda by 2. This A, B A, B will get cancelled. The remaining term is here, only this term. Again, from this term we can take the Rn square upon 2 common. The remaining term is a upon 1 upon a and 1 upon b, and here only the n lambda by 2. Means we get this equation Rn square upon 2 in bracket 1 upon a plus 1 upon b equal to n lambda by 2. This 2 get cancelled. The remaining term is Rn square in bracket 1 by a plus 1 by b equal to n lambda. If we consider or if we take Rn equal to under root of n lambda fn, then substitute this value here in this equation, and solving this equation we get final equation 1 upon fn equal to 1 upon a plus 1 upon b. This equation is similar to the equation for the lengths, where a and b are the object and image distance and fn is the focal length. Here if we compare this equation, we will compare this equation with the equation of length, then we get this a and b are the images of the object and the images from the screen, and then the fn is the focal length. Now the working of the zone plate as a lens. Here we consider let the beam of monochromatic light of the wavelength lambda be incident normally on the zone plate. Here we take this source S is a monochromatic beam of light is incident on this section of the zone plate. Then they form the image on the screen at point P. The intensity of the light of point P depends upon the odd or even number zone. If the even number zone are blacked, then from this zone light will not reach to the point P. Thus the resultant amplitude of the light waves will be due to the exposed odd number of zone. Here we bracket the even number of ring, means from this zone the light will not enter to the light will not pass toward the screen. Therefore the resultant amplitude is only due to the odd number of the zone. Therefore we write here a1 plus a3 plus a5 and the so on. If we bracket the odd number of the zone, it means that from the odd number of zone the light will not reach towards the point P. Only the light get passing from the even number of the zone. Therefore for the odd number of the zone are bracket, the resultant amplitude will become a2 plus a4 plus a5 and the so on. When the whole wavefront is unobstructed, means if we not colored or not bracket the alternate zone, then the resultant amplitude will be is a a1 minus a2 plus a3 minus a4 and the so on. This equation can be written like this. If n is very large, then this can be written a1 by 2 only. This is the equation number 8. This represents the resultant amplitude only due to the first half period zone, while the 6 and 7 represent the resultant amplitude due to the either all odd numbers or even number of the zone. Here in this equation, in first 6 and the 7th equation, here the resultant amplitude is only due to the zone only due to the odd number of the zone, and here the amplitude is only due to the even number of the zone. But if we not bracket the alternate zone, then the amplitude is only due to the first half period zone. Then thus the amplitude A dash is several times greater than the A. Therefore from this equation 6, 7 and 8 equation we can say that this A is less than the A dash, means A dash is several times greater than the A if the alternate zones are not blacked. Then the comparison between the zone plate and the convex lens. From the theory, we prove that the plate is act as the lens. Then we study the similarities and then there is the some similarities and the some dissimilarities between the zone plate and the convex lens. We will see the some similarities. The first is both form the real image of an object on the side other than the object. The distance of the object and image are connected together by similar formula in both the cases. Here in theory of the zone plate we derive this formula. This formula is nothing but the lens formula. Therefore we can say that in both the cases, if we study the images and this images and the sources, the images formed due to the zone plate and the due to the lens form the same formula, construct the same formula. The second is that second point is that the focal length for both depends upon the lambda, and hence both shows the chromatic aberration. Here also the f is depends upon the, here the f is also depends upon the lambda. If we rearrange this formula, you will get the f is depends upon inversely proportional to the lambda. And also in case of the lens, the lens is also depends upon the wavelength lambda, therefore it is shows the chromatic aberration. There are also some dissimilarities between zone plate and the convex lens. The first is, in case of the convex lens, the rays are brought to the focus by refraction, while in case of zone plate, the image is formed by the diffraction. In case of the convex, all the rays reaching this image point have the same optical path, while in zone plate, the waves reaching the image point through two alternate zone two alternate zone differ in a path by lambda. So differ in a path by lambda by 2. Here the path difference in a zone plate is always the lambda by 2. Third point is that the image due to the convex lens is more intense than the image due to the zone plate. Here, then the difference between the zone plate and the convex lens, we differentiate the some point. Here the first point is that the zone plate has the several foci, but the convex lens has the fixed single focus. Then the focal length of the plate for violet is the greater than that for the red color, but in a convex lens this is the reverse condition, means the focal length of the violet color is less than the focal length of the red color. In case of the convex lens, means it shows the reverse condition in both in a convex lens. As the foci are the different, here as the different foci, therefore if there are the different foci, then that different foci shows the different intensities and will form the different image having the different then will form the different image showing the different intensities. Here the lens has the single foci, therefore they will form the single image and having the high intensity. The zone plate work as the converging as well as the diverging lens. A converging lens can work as a diverging lens if it is placed in the medium denser than the medium of the lens. It is only possible in this case. This is the difference between the zone plate and the convex lens. Thank you.